The VIC-20 is an 8-bit home computer which was sold by Commodore Business Machines. The VIC-20 was announced in 1980, roughly 3 years after Commodore's first personal computer, the PET. The VIC-20 was the first computer of any description to sell 1 million units. History. Origin. Marketing. The VIC-20 was intended to be more economical than the PET computer. It was equipped with 5 kilobytes of static RAM and used the same MOS 6502 CPU as the PET. The VIC-20's video chip. The MOS technology VIC was a general-purpose color video chip designed by Al Charpentier in 1977 and intended for use in inexpensive display terminals and game consoles. But Commodore could not find a market for the chip. As the Apple II gained momentum with the advent of VisiCalc in 1979, Jack Tramiel wanted a product that would compete in the same segment. To be presented at the January 1980 SAE. For this reason Chuck Peddle and Bill Silas started to design a computer named Toy. The Toy computer failed to materialize, mostly because it required an 80-column character display which in turn required the MOS technology 6564 chip. However, the chip could not be used in the Toy since it required very expensive static RAM to operate fast enough. In the meantime, freshman engineer Robert Janis at MOS Technology had designed a computer in his home dubbed the Micropet and finished a prototype with some help from Al Charpentier and Charles Winterble. With the Toy unfinished, when Jack Tramiel was confronted with the Micropet prototype, he immediately said he wanted it to be finished and ordered it to be mass-produced following a limited demonstration at the SAE. The prototype produced by Janis had very few of the features required for a real computer, so Robert Russell at Commodore headquarters had to coordinate and finish large parts of the design under the code name Vixen. The parts contributed by Russell included a port of the operating system taken from John Fegan's design for the Commodore PET, a character set with the characteristic PETSCII, an Atari 2600 compatible joystick interface, and a ROM cartridge port. The serial IEEE 488 derivative interface was designed by Glenn Stark. Some features, like the memory add-in board, were designed by Bill Siler. Altogether, the VIC-20 development team consisted of 5 people, who referred to themselves as the VIC Commandos. According to one of the development team, Neil Harris, W.E. couldn't get any cooperation from the rest of the company who thought we were jokers because we were working late. About an hour after everyone else had left the building, we'd swipe whatever equipment we needed to get our jobs done. There was no other way to get the work done. They'd discover it was missing and they would just order more stuff from the warehouse. So everybody had what they needed to do their work. At the time, Commodore had an oversupply of 1 kbit x 4 SRAM chips. So Tramiel decided that these should be used in the new computer. The end result was arguably closer to the PET or Toy computers than to Janis' prototype, albeit with a 22-column VIC chip instead of the custom chips designed for the more ambitious computers. In April 1980 at a meeting of general managers outside London, Jack Tramiel declared that he wanted a low-cost color computer. When most of the GMs argued against it, he said, "The Japanese are coming, so we will become the Japanese." This was in keeping with Tramiel's philosophy, which was to make computers for the masses, not the classes. The concept was championed at the meeting by Michael Tomchik, newly hired marketing strategist and assistant to the president, Tony Tokai, general manager of Commodore Japan, and Kit Spencer, the UK's top marketing executive. Then, the project was given to Commodore Japan. An engineering team led by Yash Terakura created the VIC-1001 for the Japanese market. The VIC-20 was marketed in Japan as VIC-1001 before VIC-20 was introduced to the US. When they returned to California from that meeting, Tomczyk wrote a 30-page memo detailing recommendations for the new computer, and presented it to Tramiel. Recommendations included programmable function keys, full-size typewriter-style keys, and built-in RS-232. Tomczyk insisted on user-friendliness as the prime directive for the new computer to engineer Yash Terakura, and proposed a retail price of $299.95. He recruited a marketing team and a small group of computer enthusiasts, and worked closely with colleagues in the UK and Japan to create colorful packaging, user manuals, and the first wave of software programs. Scott Adams was contracted to provide a series of text adventure games, with help from a Commodore engineer who came to Longwood, Florida to assist in the effort. 5 of Adams's Adventure International game series were ported to the VIC. They got around the limited memory of VIC-20 by having the 16 kilobytes games reside in a ROM cartridge instead of being loaded into main memory via cassette as they were on the TRS-80 and other machines. The first production run of the 5 cartridges generated over $1,500,000 in sales for Commodore. While the PET was sold through authorized dealers, the VIC-20 primarily sold at retail, especially discount and toy stores, where it could compete more directly with game consoles. It was the first computer to be sold in Kmart. Commodore took out advertisements featuring actor William Shatner as its spokesman, asking, "Why buy just a video game?" Television personality Henry Morgan became the commentator in a series of Commodore product ads. The VIC-20 had 5 kilobytes of RAM, of which only 3.5 kilobytes remained available on startup. This is roughly equivalent to the words and spaces on one sheet of typing paper, meeting a design goal of the machine. The computer was expandable up to 40 kilobytes with an add-on memory cartridge. Although the VIC-20 was criticized in print as being underpowered, the strategy worked. In 1981, Tomczyk contracted with an outside engineering group to develop a direct connect modem on a cartridge, which at $99 became the first modem priced under $100. The VIC modem was also the first modem to sell over 1 million units. VIC modem was packaged with $197.50 worth of free telecomputing services from the source, CompuServe Dow Jones. Tomczyk also created a SIG called the Commodore Information Network to enable users to exchange information and take some of the pressure off of customer support inquiries, which were straining Commodore's lean organization. In 1982, this network accounted for the largest traffic on CompuServe. Decline in 1982, the VIC-20 was the best-selling computer of the year, with 800,000 machines sold. 1 million had been sold by the end of the year, and at 1.9 thousand units a day were being produced. That summer, Commodore unveiled the Commodore 64, a more advanced machine with 64 kilobytes of RAM and considerably improved sound and graphics capabilities. Sales were slow at first due to reliability problems and lack of software, but by the middle of 1983, the latter had turned into a flood and VIC-20 sales abruptly plunged. It was quietly discontinued in January 1985. Perhaps the last new commercially available VIC-20 peripheral was the VIC-Talker, a speech synthesizer. Ahoy! In January 1986 wrote when discussing it, "Believe it or not, a new VIC accessory. We were as surprised as you." Applications before the VIC-20's release. A Commodore executive promised that the forthcoming computer would have enough additional documentation to enable an experienced programmer, hobbyist, to get inside and let his imagination work. Because of its small memory and low-resolution display compared to some other computers of the time, the VIC-20 was primarily used for educational software and games. However, productivity applications such as home finance programs, spreadsheets, and communication terminal programs were also made for the machine. Its high accessibility to the general public meant that many software developers cut their teeth on the VIC-20, being introduced to basic programming or assembly language. Several computer magazines sold on newsstands, such as Compute, Family Computing, Run, Ahoy, and the CBM-produced Commodore PowerPlay, offered programming tips and type-in programs for the VIC-20. Many VIC users learned to program by entering, running, debugging, studying, and modifying these type-ins. The ease of programming the VIC and availability of an inexpensive modem combined to give the VIC a sizable library of public domain and freeware software. Although much smaller than that of the C64, this software was distributed via online services such as CompuServe BBSs, as well as offline by mail order and by user groups. The VIC's low cost led to it being used by the Fort Pierce, Florida Utilities Authority to measure the input and output of two of their generators and display the results on monitors throughout the plant. The utility was able to purchase multiple VIC and C64 systems for the cost of one IBM PC-compatible system. As for commercial software offerings, an estimated 300 titles were available on cartridge, and another 500-plus titles were available on tape. By comparison, the Atari 2600, the most popular of the video game consoles at the time, had a library of about 900 titles near the end of its production life. Most cartridge games were ready to play as soon as the VIC-20 was turned on, as opposed to games on tape which required a time-consuming loading process. Titles on cartridge included GORF, Cosmic Cruncher, Sargon 2 Chess, and many others. A handful of disk applications were released for the VIC-20. Technical specifications. Basic features: the VIC-20 had proprietary connectors for program expansion cartridges and a tape drive. It came with 5 KB RAM, but 1.5 KB of this was used by the system for various things, like the video display, and other dynamic aspects of the ROM resident basic interpreter and kernel. Thus, only 3,583 bytes of basic program memory for code and variables was actually available to the user of an unexpanded machine. The computer also had a single D9 game controller port, compatible with the digital joysticks and paddles used with Atari 2600 video game consoles, a serial bus for daisy-chaining disk drives and printers, a TTL-level user port, with both RS-232 and Centronics signals. Importantly, like most video game consoles and many computers at the time, the VIC had a ROM cartridge port to allow for plugging cartridges with games and other software, as well as for adding memory to the machine. Port expander boxes were available from Commodore and other vendors to allow more than one cartridge to be attached at a time. Cartridge software ranged from 4 to 16 kilobytes in size, although the latter was uncommon due to its cost, and only larger software houses produced 16 kilobytes cartridges. The graphics capabilities of the VIC chip were limited but flexible. At startup, the screen showed 176 x 184 pixels, with a fixed color border to the edges of the screen. Since an NTSC or PAL screen has a 4:3 width-to-height ratio, each VIC pixel was much wider than it was high. The screen normally showed 22 columns and 23 rows of 8-byte pixel characters. It was possible to increase these dimensions up to 27 columns, but the characters would soon run out the sides of the monitor at about 25 columns. Like on the PET, 256 different characters could be displayed at a time, normally taken from one of the two character generators in ROM. Normally, the VIC-20 was operated in high-resolution mode, whereby each character was 8 x 8 pixels in size and used one color. A lower-resolution multicolor mode could also be used with 4 x 8 characters and 3 colors each, but it was not used as often due to its extreme blockiness. The VIC chip did not support a true bitmap mode, but programmers could define their own custom character set. It was possible to get a fully addressable screen, although slightly smaller than normal, by filling the screen with a sequence of different double-height characters, then turning on the pixels selectively inside the RAM-based character definitions. The Super Expander cartridge added basic commands supporting such a graphics mode using a resolution of 160 × 160 pixels. It was also possible to fill a larger area of the screen with addressable graphics using a more dynamic allocation scheme, if the contents were sparse or repetitive enough. This was used, for instance, by the game Omega Race. The VIC chip did not support sprites. The VIC chip had readable scan line counters but could not generate interrupts based on the scan position. However, the two VIA timer chips could be tricked into generating interrupts at specific screen locations, by setting up the timers after a position has been established by repetitive reading of the scan line counter, and letting them run the exact number of cycles that pass by during one full screen update. Thus it was possible, but difficult, to e.g. mix graphics with text above or below it, or to have two different background and border colors, or to use more than 200 characters for the pseudo-high-resolution mode. The VIC chip could also process a light pen signal, but few of those ever appeared on the market. The VIC chip had 3 pulse wave sound generators. Each had a range of 3 octaves, and the generators were located on the scale about an octave apart, giving a total range of about 5 octaves. In addition, there was a white noise generator. There was only one volume control, and the output was in mono. The VIC chip output composite video. Commodore did not include an RF modulator inside the computer's case because of FCC regulations. It could either be attached to a dedicated monitor or a TV set using the external modulator included with the computer. Memory expansion. The VIC-20's RAM was expandable through the cartridge port. RAM cartridges were available in several sizes: 3 KB, 8 KB, 16 KB, 32 KB, and 64 KB, the latter two only from third-party vendors. The internal memory map was dramatically reorganized with the addition of each size cartridge, leading to the situation that some programs would only work if the right amount of memory was present. The most visible part of memory that was reorganized with differing expansion memory configurations was the video memory. This was because the video chip could only use the built-in memory for its display data, and at the same time free memory had to remain contiguous for the basic interpreter to be able to use it. An unexpanded VIC had 1 KB of system memory, followed by a 3 KB whole, then 4 KB of contiguous user memory up to address 8191. The 3 KB cartridge would fill the whole, so on unexpanded and plus 3 KVICs. The video area was placed at the top of user memory. If an 8 KB or 16 KB cartridge was added instead, this memory appeared at addresses above 8 KB. The video memory was then placed at the start of user memory at 4 KB, just above the whole, to provide the maximum amount of contiguous user memory. The 32 KB cartridges allowed adding up to 24 KB to the basic user memory, together with the 3.5 KB built-in user memory. This gave a maximum of 27.5 KB for basic programs and variables. The extra 8 KB could usually be used in one of two ways, set by switches. Either it could be mapped into the address space reserved for ROM cartridges, which sat behind the I/O register space and thus was not contiguous with the rest of the RAM. This allowed running many cartridge-based games from disk or tape and was thus very useful for software pirates, especially if the RAM expansion allowed switching off writing to its memory after the game was loaded, so that the memory behaved exactly like ROM. or 3 kilobytes of the 8 kilobytes could be mapped into the same memory hole that the 3 kilobytes cartridge used, letting 5 kilobytes life-value. These 3 kilobytes were contiguous with the rest of RAM, but couldn't be used to expand basic space to more than 27.5 kilobytes. Because the display data would have had to be moved to cartridge RAM, which was not possible. Some 64 kilobytes expansion cartridges allowed the user to copy ROM images to RAM. The more advanced versions even contained an 80-character video chip and a patched BASIC interpreter which gave access to 48 kilobytes of the memory into the 80-column video mode. As the latter type of cartridges, marketed primarily in Germany, were not released until late 1984, 2 years after the appearance of the more capable C64, they went by mostly unnoticed. Reception. While noting the small screen size and RAM, Byte stated that the VIC-20 was unexcelled as low-cost, consumer-oriented computer. Even with some of its limitations, it makes an impressive showing against the Apple II, the Radio Shack TRS-80, and the Atari 800. It praised the price, keyboard, graphics, documentation, and ease of software development with the kernel.